Hey guys, how are you all? So, welcome to the third project lecture. So, in this project, basically your third project, I will be explaining you a topic like I have already explained you that topic in theory. That topic is your multiple linear regression. Now I will we will be solving a project which is your which is completely based on your multiple linear regression. But the thing is, guys, in this project, you have to be more than you have to concentrate more than everything. Like you have to leave everything aside because this is the most important project. Trust me, like 80% of the interviews, in the interviews, they'll ask you some or the other thing regarding this project. I'm sure about that. So, and this project is also a little trickier. So you have to put a lot of lot of hard work to grasp the knowledge in this project. So basically, I'll try to explain each and everything very slowly. I'll draw the uh, required diagrams and all. I'll try to explain each and every point after that. So let's start. All right, without wasting any time, let's start. Even I would request you to take a notebook along, like I always request, and keep marking or noting the important points and the equations or the library equations which I use, like sklearn, dot cross validation, everything. You just write that down and mention in front of that in your own words, in your own language, why it is used and how it is used. Because basically the things I ask you, like the machine learning thing is completely from the basic, but I'm not explaining you entire Python, Panda or NumPy thing, because it will extend this course to 50 to 60 hours or even 100 hours if I explain each and everything. Right, I hope you understand. So I request you to keep learning or keep revising your Python, NumPy, and your simple libraries and simple things. Okay, so basically, whatever it will be required in my project by creating any model or machine learning, anything regarding Python or anything, I'll explain that. But data sets and basic things that you have to learn by your own. Okay, so let's start. All right, so you have to open your Anaconda again and then create new Python 3. This I have explained in my first lecture. So, all right. So let first thing, as you have seen in every project, I import three files. Here also I'll do the same. So I'll just import my NumPy, Pandas, and Matplot libraries. Okay. Import NumPy as MP. Import Pandas as PD. Import Matplot library dot pyplot as PLT. So this is how we import our libraries. Then let me just put up the data set, which I'll just show you the data set on which we will be working on the multiple linear regression project. PD dot read underscore CSV. Everything is same. Wherever there is a difference, I'll let you know. This is my file name 50 startups 50 startups dot CSV. Okay. All right. So let me just increase my brightness. Okay. So let me show you the data set now. All right. So guys, this is my data set. This is again a subset of data set with 50 rows, just to explain you multiple linear regression. So this is nothing but your if anyone have ever worked with any startup company or like has an idea how startup company financial and marketing and those thing works. So this is you must have seen such file there a lot. Okay, so this is your R&D spend, administration, marketing spend, state profit. So here, like obviously I'll take like what you must have seen there are like there are people who wants to finance or like they want to spend money on the company. So they basically look on the profit thing, like which company or which part, like in which city they are making the most of the profit. Obviously, they'll, I'm sorry, they'll apply there, like they'll put all the efforts there. So this is the how they do that. Basically, they have the company chart, such chart or data set like this, and they run the machine learning algorithms here, and they find out and they used to like pull out the details which at which area, New York, Florida, or California, where they are making the most of the profit, and at that point they'll invest the most. I hope you're getting it. Like I'm just trying to explain the data set here. Like this is not a part of your machine learning to understand the data sets. Like there, a BA guy or like business like analyst guy that he will be explaining you everything there. So you don't have to worry when you're working in a company. I'm just telling you about that. So this is how that data set looks like. Okay, and here you can see easily that this is not a one-dimensional X. There is no one-dimensional X data. There are in fact 3 to 4 values of X which we can take, and obviously we'll take the profit as Y because we need to like investors will see the profit. Finally, we have to predict the profit, like which will company can do the most of the profit. He'll invest in that, right? So this is how we have to do. All right. So this is good up to this. Okay, cool. So now the same thing we have to do for everything. The first thing was importing all these three libraries. Second thing is using the pandas. We have to load the data to the Python, and then the next thing is we have to see what values of x we have to take and what values of y we have to take. So for x, everything will be same, simple Python coding. X we are taking x equals to dataset dot ilog. Yeah. So those who don't know about like very those who have very less knowledge so about Python, we are taking all the 50 rows here. This comma or like colon colon thing represents that we are taking all the values, all the 50 rows here in the x part, and in the y part we don't have to take the like we don't have to take the let's say the administration part. All right, so we don't have to take the administration part. So I'm just giving you example here, guys. Okay, make sure I'm just giving you example. We are not working on real data set. I'm just trying to explain some points here. So if we are taking all the values here, instead I just want to like let's say I just want to take administration here. So if you have knowledge of index, so this is your first, this is your second, third, fourth, fifth. So I just want to take, I don't want to take the like administration parts. For that I'll just simply say all the columns minus first index. First index will be your administration. Okay, dot values. This will be same. Similarly for y, dataset dot ilog. For y, I'm taking all the rows again, and for y, I'm taking let's say 1, 2, 3, 0, 1, 2, 3, 4. This is our y, and this is our fourth index, so I have to take 4. Okay, and we are keeping it like I hope you are keep are able to understand that we are taking x, the dimension of x is 3, like 1, 2, and 3. We are just ignoring the administration part now, for now, to make the things easy and to explain the project thing. We are just not taking the administration part, so making the dimension as 3, and y is my profit dot values. So this is how we like we have seen up to this, we have seen in every project. Like already we are done with 2 projects and we have seen up to this. So to check the values of x and y, just say x, shift enter, and you can see everything is here in an array form. Each and every value is here, right? You can have a good view of everything. Now let's check the value of y. Again an array, and everything is here in y as well. But in multiple linear regression, there is a slight problem, like a difficulty. You can say there is a difficulty here, and that I will be explaining you here. Okay, let's say I have 4 columns. Um, I'm very bad with diagrams. Let's say we have C1 column, C2 column, C3 column, C4 column. We have some values here. All these values are numbers, guys. All these values are numbers in numbers. But in C4, the values are in like alphabets, or you can say in, you simply say now alphabets to understand things. Let's say, for example, I'm giving, let's take Delhi, Bhopal. These are my cities in India. Nagpur. Again, we have Delhi. And let's say Nagpur is repeated. All right. So here, guys, what is my straight line equation for multilinear regression if we have more than one dimension? It was y equals to m1x1 plus m2x2 plus m3x3 plus m4x4. Remember, x1 is nothing but your column 1 values, 2, 3, but in your column 4, your x4 will be alphabetical, right? If you can see, like in an equation, in any equation, if every value is a number, you just can't put Delhi, Bhopal, like it will give an error simply, like you know, right? It will give simply an error, like we cannot even calculate or even think to calculate such thing. So like Delhi, Bhopal, Nagpur, and Delhi repeating again, we cannot do that. So this is a major problem here. Like the values are here in, let's say, a string. So there is a solution. Every problem has one solution. Even big data I have now Hadoop or Apache Spark as a solution. So everything has a solution here. And the solution for this is, there is a method known as one hot encoding. This is a solution to this problem. Like there are many other, but for now we are seeing this one hot encoding. So guys, in this again, guys, I'm telling you one thing, that I'm going slow to make you things clear in your mind. Okay, so basically in one hot encoding, uh, like some basic points about this thing is, like it will look for unique values in this. Like if we have a data set like this, it will look for unique values. Like uh, it will take Delhi, Bhopal, Nagpur. Now Delhi and Nagpur are repeating, so it won't take the rest values. So it will take each value, if they are repeating, it will take only one time, and it will do something. I have to delete everything from this screen to explain you another thing here is, guys, I'm again telling you this is the most important part of multiple linear regression, and the project we will be working after this is on the same topic, one hot encoding. So make sure you are concentrating. All right. So guys, just remember, like I have to erase the screen. Like we have three values here: Delhi, Bhopal, and Nagpur, which are like unique. These are not unique because like it's repeating. So unique values are only three here. So what one hot encoding will do here is it will add three columns to the same data set. Let me explain that. If this is our data set, same data set, C1, C2, C3, C4. C4 is it was Delhi, Bhopal, Nagpur, Delhi, Nagpur. Our data set was somewhat looking like this. So what one hot encoding will do, it will create three columns, like the number of unique values, whatever the number of unique values are there, it will create same number of columns. How? I'll just show you. Instead of like these are the three unique values, so it will keep Delhi here. It will create one column named as Delhi, Bhopal, Nagpur. Okay, and what it will do, like it will be using some figures like 0 and 1. So like if in the column, like if in this column, basically the column which is giving us a lot of problem, and because of that we have switched to one hot encoding solution. That column, if it has the value of Delhi, it will simply say in the column Delhi 1, in so Bhopal and Nagpur are 0 0 because there is no Bhopal and Nagpur, right guys? In Bhopal it will say there is no Delhi, so it will say 0 here, 1 here, 0 here. I hope you are understanding. 0 0 1, 1 0 0 0 0 1. This is how it will do. Now you guys, don't you think all the values are, and yeah, and finally after doing everything, it will simply delete this column. It will simply delete this column. Now don't you think guys, there are 1 2 3 4 5 6 columns. There are 6 columns, and all the 6 columns have numbers, and there are no alphabets, which will give us problem solving an equation. Don't you think there are now only numbers? But again, there is a slight problem that data scientists hate when there are number of rows, like number of columns, they hate that. So what they try to do is they try to reduce the number of columns. So I'll just show you how. So basically, like if we are a data scientist, we don't want so many columns here. So using one hot encoding, what we will be doing is that, guys, tell me, tell me one thing here. What is the, if we add all these values, if we add all these values in a row, like I'm talking about this row, what will be my answer? 1, right? Second one, 1. Third one, fourth one. Like 1 plus 0 plus 0, 1 plus 0 plus 1 plus 0, 0 plus 0 plus 1. This is how, if we add, our all the values will be 1. So now look carefully. If I just simply remove the Nagpur column, I'm just removing this column. Don't you think with these two values, like if I have Delhi and Bhopal, Delhi has 1, Bhopal has 0, we can find out that okay, Nagpur should be 0, because if we add them, everything should be 1. Don't you think we can recall that? There is no need of Nagpur here, because we can simply calculate that. Like Delhi is 1, Bhopal is 0, Nagpur should be 0, obviously 0, because the total should be 1. Here Delhi is 0, Bhopal is 1, so Nagpur should be 0. Same thing. Here Delhi is 0, Bhopal is 0, so Nagpur should be 1. Right? So we don't need these two rows. We have removed this column, then we have removed this column. So now we have simply reduced these columns, and we have simply removed the two columns here. This basically, we are doing this to just shorten and make things easier to work on our model, especially when we are working with multiple linear regression. Guys, like I am trying my best to explain you in this way. Like if you'll notice in any YouTube or anything about they'll not even try to explain you like this. So before stepping into the project thing, I want your fundamentals to get completely clear if you're working with this. All right. So now, don't you think, in short, like if I summarize everything in short, uh, we have, if we have n number of columns, we are reducing n number of columns to n minus 1 by just removing this extra thing about 1 and 0. So this we usually do in our one hot encoding. All right, so basically what is happening here is, this is the one way. This is one way of solving such problem. Like if there are many number of columns, so this is one way. I hope you have noted it down. Please pause the video and note everything down, because I'm moving to another solution. Like there are many solutions, but I will explain you two solutions, how we can do that. Now let's switch to another solution, which is known as, okay, before explaining what it is known as, I'll tell you one thing. So, okay, so in one hot encoding, uh, now you have a good understanding that how to reduce one column. Now, guys, tell me one thing. If there are column number of the size of the column is 3000 or 4000 or 10,000, there can be chances, right? So data scientists, I have seen blood pressure of data scientists getting high or low after seeing such columns and to work on this. Trust me, guys. And with the unique values of everything, that's a hell lot of headache. So for that, there is another solution, which is known as response encoding. All right. This is basically when we are working with big data. Usually you won't be working with this, but you should know. Like this is another solution. This has no technique or like any algorithm or any equation to write. Like in my previous example of one hot encoding, we used to write some algorithms so that it is now like remove one column and everything. But here it is completely based on art, your mind art, how you see the things and how you fix it. Like there is no fixed rule here. It's just up to you how you do that. I'll just give one simple example, which when I was working in a company and I have to use this response encoding thing in a huge data set, what I have tried and it got successfully accepted by my manager. I'll just giving by giving you example. I just try to do that. I explain you guys. Let's say we have another data set here, and I have a column here named as country. Let's say I have column one something name or anything. Then we have column two, and we have heights. What I was supposed to do in that is we have like it was not. This is just an example. I'm trying to give an idea of what it isn't the exact thing what I was working, but I just got an idea. Like let's say there's a country. Let's say US, India, Sri Lanka, and let's say Germany. Let's say there are four countries. There are some column. Let's say how far they are from this point, or let's say these are the coordinates or anything. And these are the heights here of like the person in living in USA with this and this column has what could be the height. So what I have did here in this project thing is using response encoding, because it is completely based on your mind art, how you use your mind. What I did, I went to Google, I just typed average height of people in USA. And like, for example, it came to be 162 centimeters. Average height in India, it came to be 160. Average height in Sri Lanka, it came to be 155. Average height in Germany, it came to be 163, for example. Okay. So now don't you think I'm just keeping these values as my, like I just simply removed my country here, and instead of country for USA I have just kept on average predicted value of 162, India 160, Sri Lanka 155, and Germany as 163. Now this is uh, how I have replaced in a meaningful way, and I have also replaced one column which has uh, data as a string, but I have replaced that into a meaningful column. It has numbers. So basically, what I'm saying, the thing which we are replacing, the columns which we are replacing, is nothing but your categorical. We call it as categorical values. These are our categorical values which we don't want in our columns at all. And this is how, like, these are the two methods. There are two, three other methods also which are not widely used. So most widely used is your one hot encoder. So these are the basic two things. Like this, we work with like, big data, usually big data or with has a lot of columns. I hope you are cleared up to this. I have tried my best to explain you things in this way. Okay. So in this project, which I have shown you 50 things, 50 something, I've never touched that project yet. So let's do it together for the first time. So we will be using one hot encoding thing because there are very less number of columns. Okay. So this is our data set here, and we will, and yeah, if I want to explain the things here in this thing, you can see we have one categorical column named as state, in which I have New York, California, Florida, and it is repeating. New York is repeating, Florida is repeating, California is repeating, Florida again. So this is the value. Like I think there are three unique values: New York, California, Florida. I hope there are no other values. So yeah, there are three unique values: New York, California, and Florida. And this is our categorical column, which we have to remove in a way that we just can transform this into a understandable column to the machine learning algorithms, or basically our model. Okay, I hope you are getting up to this. So again, we have to import something from my sklearn package that I'll show you how to do that. All right. So from sklearn dot pre, I think I have shown you pre-processing before. Pre-processing, sklearn dot pre-processing. I'm importing my label encoder and one hot encoder. Okay, so I'll be exploring two libraries here from my sklearn pre-processing, which is my. Alright guys, so from sklearn pre-processing, I'm importing label encoder and one hot encoder. So now let's create an object for label encoder first. So it will be label encoder as label encoder empty class. Alright, now what I have to do here is okay, there is a spelling mistake. Coder. Okay, now x, here x I have to mention as like I'll just write the equation first, then I'll explain you. Comma 3 label encoder dot fit transform x all the rows 3. Alright guys, what I did here is, here I'm saying that for my third column and all the rows and third column, with this label encoder, start applying my method for all the rows in my third column. Basically, in short, it will start searching for all the unique values in my third column. Alright, it will start searching all the unique values. Now let's move to the another library which we just imported, which is our one hot encoder, the most important one. Let's create an object for that. One hot encoder, to one hot encoder. What we are working on, like what row, what column we have to remove. It is a categorical column. So categorical underscore features, and what is my column here? It is my third column. Alright, so this is how we create an object for one hot encoder, and in class we just pass categorical features for the third column. Okay, basically what it will do here is it will be creating your one hot encoder for the third column. All right, after this guys, since we have transformed this, I just have to uh, like run each and every step again, because there will be some rows at the bottom already created like this. All right, so we have done with one hot encoder. Now let me put x as, like I want to see x into like array form. For that I'll just say one hot encoder dot fit transforming x to array. All right, this is how we do that into an array form, and this is the same thing array which I have just did, and it since I have not transformed, it was already there, so I have to remove everything to create this video. So you can see that this is how it has created everything into an array form. Now guys, I want to explain here one thing. If you remember in my like theoretical part there, what basically it do, one hot encoder, what we were doing, we were just creating, like it was Delhi, Bhopal and Nagpur, there were three unique values, and Delhi and Nagpur was repeating. Guys, if you remember, I have created three columns of Delhi, Nagpur and Bhopal, and under that I have just said 0 1 0. If Delhi is occurring, so it named as 1. If it's Bhopal is not occurring on the same row, 0 and 0, and sum is the total sum was used to be 1. Now guys, tell me one thing, don't you think this thing what we have just uh, transformed, don't you think my it is now created similar to that 0 0 and 1, and then all the rest three rows, rest three columns for the x, all the rest three columns, you can see 1 0 0 0 1 0 0 0 1 0 1 0 0 0 1 0 1 0 0. Don't you think it is the same thing which I have just explained you, right? So this is how we do the one hot encoder thing and create the x here. Now once we are like done up to this, or once we have created the one hot encoder thing, our next step is to remove one extra column. If you again remember, I was removing the third column because we know 0 plus 1 plus 0 equals to 1. We know that like sum of these will obviously 1. So if we don't have any column, let's say the first, we don't have first column, and we know the rest two columns, we will be like, we can give a guess that it will be 0. Like we know this is 0 and 1, it will be obviously 0. This is 0 and 0, it will be obviously 1. We know that, right? So the next step is we have to remove one column. Let's take like first column we have to remove, because we will be knowing then, like basically we have to reduce all the column size as much as we can. So how about let remove the first column, so that now we are doing n, we are changing n as n minus 1. I have also explained that, right? So x equals to x, we are taking all the rows we are taking all the rows, comma, from, like this is my zeroth element, right? The zeroth index. We are just, if we want to ignore this 0, so we can just say I'm taking from 1 to all the rows, right? So from one column I'm taking all the column. This is how we have to do. Now just look how it will look like. Now see guys, it has just simply removed my first column, so it is just 0 and 1 and then the normal values, right? 0 0 normal values. This is how it is done. Simple Python technique and nothing else. Now the final part, like we are now almost done with our multilinear regression part of the project. This was the like I was saying, this was the part which you have to give more focus, like you have to mm, like focus a lot. Now everything is same. The next part is we have to convert everything into training and testing set. If you remember, we have already did that in our previous projects. We have to do the same. So same thing, from sklearn dot cross validation from cross validation of sklearn, we have to import train underscore test underscore split. This will split our entire dataset into training and testing dataset. Remember guys, we have did that. This is the easiest pass. This is just an warning, so you can just ignore. Now train underscore x underscore train comma x underscore test y underscore train y underscore test equals to train. Okay, just ignore this. Okay, so x train y x test y train y test as train underscore test underscore split. Now let us split into 80% to the testing part and like 80% to the training part and 20% to the testing part. Let us do in this way. All right, so x and y comma test size equals to, I'm taking as my test size as 0.2, and let's do a random state here, which is not required, but if you want you can do that. Random state equals to, let's take 0. This what this equation did is it has divided the entire data set which we have right now here into 20% into the testing part and 80% to the training part. All right, now like we have done in simple regression almost same thing. sklearn dot linear underscore model. I am importing linear regression. I'm importing linear regression. Then I will create an object for that. Not like this. I'll do regressor. Regressor linear regression. Regressor. Now I have to fit the values right. Yeah. X train, comma y train. All right, all good. So basically we are almost done with the project. Now we have to do the prediction part. Like we have to predict y, which is very similar to our previous projects. Y prediction as regression dot predict x underscore test, and did some mistake. Y prediction equals to, oh, it's not regression, it's regressor. All right, predict. Yeah, all good. So guys, I'm sure you'll end up doing such silly mistakes, so make sure you are doing it correctly. So if you want to see the y predicted values, so it has predicted these values for me as y, and if you want to compare it with the test values, you can simply do that again. And again, if you want to do, so guys, here if you want you can do the simple comparison and find the accuracy. And this is how we do and create the linear regression, multiple linear regression. Basically I have tried my best to explain the things here. So guys, I hope you will practice this a lot. I have attached the same data set here. You can try practice with the same data set as well as
You can use the other data set from my other projects as well to practice and get your hands strong on this multiple linear regression. You can see I too have some of the other problems doing this project. So even with 3-4 years of experience, you'll end up doing some of the other mistakes, or like spelling mistakes, or that's obvious, like that's human error. Everyone can make, everyone do that. That's okay. But the thing is, what I want to do, want to remember is, I want you to have all the fundamentals clear in your inside your mind, as well as you should not forget the what package you are importing, what libraries you are importing, and each and everything. All right, so guys, this is up to this in this video. Let's uh, let's see you guys in the next video. Thank you so much, guys.